What's up? It's still me, great teacher. Now dressed up as the little prince. I know, it's a bit cringe, but instead of the little prince, is the little prince. If you know what I'm saying. But um, this was a dare. This is a joke, you know. They keep calling me the little prince at work with my students, and I'm like, well, I'm gonna dress up as the little prince, so why not? So here it is, and yeah, the distance formula and the midpoint formula. So join the little prince as we hop on one world to another. Let's just jump right into it.
The distance formula is represented by d is equal to the square root of the quantity x sub 2 minus x sub 1 raised to 2 plus the quantity y sub 2 minus y sub 1 raised to the power of 2. The distance formula is something that we use in order to find the length of a line segment given the coordinates of its endpoints. Hence, you have here on the screen, it shows x sub 1, y sub 1, and x sub 2, y sub 2. Those are our 2 points. I would like to put this disclaimer now. Always remember, we're talking about coordinates here, points in the Cartesian coordinate system or plane, meaning each point is represented by x and y. The reason why there's x sub 1, y sub 1 is because it refers to our first point. That's the use of the subscript there, while x sub 2, y sub 2 refers to the second point. I hope that is clear now. Now I'm going to show you guys the quick derivation of the formula of distance. So in order for us to derive what the distance formula is, or to get where it came from, we will be needing the use of 2 points first. So as you can see earlier, we used 2 points A and B, where A is our x sub 1, y sub 1, B is our x sub 2, y sub 2. In order for us to derive the formula, we're going to need another point. Again, we're just going to need that point for derivation because we have to form a right triangle. So as you can see here, this point C is represented by x sub 2, y sub 1 because it is the same x with B and the same y with A. As we continue with this one, we will now be able to use the Pythagorean theorem because as you can see here, when you draw something like this in the Cartesian coordinate plane, it forms a right triangle. Hence, we will now be able to get it by using the Pythagorean theorem. The AB here is our hypotenuse because the right angle is formed at angle C. So we have to get the distance from A to C and from B to C. In order to do that, it's as simple as doing the following. So we have that the representation AB squared, which is the hypotenuse, is equal to AC squared, which is one of the legs, and at the same time BC squared is another leg. So we get AC squared by having x sub 2 minus x sub 1. While for BC squared, we get that by having y sub 2 minus y sub 1. And using that by substitution, we're going to get the following. AB squared is equal to the quantity x sub 2 minus x sub 1 raised to the power of 2 plus the quantity y sub 2 minus y sub 1 raised to the power of 2. In order for us to get the measurement of AB, all we have to do is to get the square root of both sides. Hence, the distance formula. So if you're wondering why are we subtracting x sub 2 and x sub 1 and y sub 2 and y sub 1 to get the distance, you can try to put numbers on it. Like for example, point A is located at, as you can see here, the x of that is 2. So from the origin 1 to the x of that is 2. While for C, that's roughly what? 4, 5, 6, 7, 8, 9, 10, 11, 12. So if you count their distance from A to C, it's actually 10 units. And you get that by having 12 minus 2. Similar with your y. Hence the representation for AC and BC. So I hope that one is clear to everyone. And instead of AB, of course, we use the letter D for distance. So what if we're trying to now to find the distance between 2 points, negative 2, 5, and 6, 11? Again, reminder, the formula looks like that, but it doesn't imply that negative 2 is x sub 2 and 5 is x sub 1. Again, remember, if you're given a point, it's x, y. Okay? So if you have this example, we can say that negative 2, 5 is our first point and 6, 11 is our second point. So, as you can notice there, we let x sub 1, y sub 1 being negative 2, 5, x sub 2, y sub 2 being 6, 11. And all we have to do now is substitute. If you look at the substitution, you have to be careful here. As indicated in the formula, it's minus, right? So 6 is x sub 2, so we substituted that. and our x sub 1 is negative 2. But look at the operation. It's minus because that's the formula. Do not write 6 minus 2 if your x sub 1 is negative 2. You have to write 6 minus negative 2. I have to emphasize that so that later on we'll just continue with the solution. Okay? If you look at here, your y sub 2 is 11 and your y sub 1 is 5. And the operation is minus based on the formula. Again, put a parenthesis for negative 2 because it has to be. When you simplify it, it's going to be 6 plus 2. So if you continue here, 6 plus 2 is 8. Why? Because copy 6, change the operation to plus, change the sign of the last term, negative 2. So it's going to be 8. And then 11 minus 5, that's going to be 6. 8 raised to 2 is 64. 6 raised to 2 is 36. So if you add it, you're going to have the distance is equal to the square root of 100. Guys, square root of 100 is simplifiable. So please indicate the answer. Square root of 100 is none other than 100. Oh, sorry. Oh, square root of 100 is 10. Sorry. Ayan, nalito na ako. So the distance is 10 units. Okay, please forgive me. Now let's have other examples here. As easy as that, right? As quick as that. So now let's use the formula here. Again, so that you won't be confused, use your A here as your first point, B as your second point, using the formula. So you're going to have 5 minus 5, negative 6 minus 1. 5 minus 5 is 0. Negative 6 minus 1 is negative 7. 0 squared, that's 0. But negative 7 raised to 2, that's 49, positive. Okay, so you're going to have AB is equal to the square root of 49. And if you simplify that, you will get the answer being 7. Then let's try the second one here. You're going to have 0 minus 6 because your x sub 2 is 0. Your x sub 1 is 6. Then here you have 6 minus negative 2. Again, do not forget this. This is the part where you might get confused. So 6 minus negative 2, that's going to be 6 plus 2. So you have negative 6 raised to 2, that's 36. Negative 6 raised to 2 is 36. 8 raised to 2 is 64. So it's going to be similar to earlier because this is going to be equal to square root of 100 or 10. Then the last example here, you're going to have 3 minus negative 5. Again, as you can notice, G is used here as the first point, H is the second point. Okay, pag first point, once again, it's repetitive, but I have to make sure you understand this. First point is represented by x sub 1, y sub 1. Second point is x sub 2, y sub 2. So doing this, 3 minus negative 5, we're going to have there 8. 1 minus 4, that's negative 3. So 8 raised to 2, that's 64. Negative 3 raised to 2, that's 9. So you're going to have the square root of 64 plus 9. If you simplify that, you're going to have the square root of 73. So if you cannot simplify it anymore, just stick with it, okay? It's much better to have the square root of 73 instead of decimals if it doesn't have a simpler version in terms of the radical, okay? Because this is going to be an important concept that you're going to apply for equations of circles. You have to make sure that when you simplify something here, just let it be. Do not put it in decimals, okay? Except for midpoint, because that's a different concept. So let's move forward. So let's say that we have here a triangle and we're going to identify if it's scalene, isosceles, or equilateral. When we say scalene, basically there is no equal sides, while isosceles implies that we have 2 equal sides. And for equilateral, we're going to have 3 equal sides, okay? So the points there are given. And again, the distance formula is not just for distance of 2 points, but also the length of a segment. So what we're going to do here is we're going to get the measurement of AB. Basically, the distance from A to B is its length. For BC, again, similar concept. And for AC. So using the distance formula, you may try it. I'll try to shut up here. You may try it. You may pause it here. Try to get the distance of AB, BC, and AC. Okay. In this case, using the formula, you're going to have this. And the answer is square root of 29. For BC, you're going to have this. And the answer is also square root of 29. And for the last one, AC, the answer is 3 square root of 2. And as you can notice here, the answers here are the measurements, right? And you have square root of 29 and square root of 29 for both AB and BC. This implies that it has 2 equal sides. That makes triangle ABC isosceles. As quick as that, okay? So it's all based off of the distance formula. Let's proceed. So now, what if we have this word problem? It says Jenny wants to install a zip line in her backyard that will start from the tree in her backyard and in her swimming pool. Lisa wants to ensure that the zip line is safe, so she asks Jenny to attach the zip line to the edge of the pool farthest from the tree. If Jenny follows Lisa's instruction, how long is the zip line in feet? So you have here the endpoints 12, 6, and then you have 6, 2. So if you continue with this, basically let's just apply the distance formula. So let x sub 1, y sub 1 be 6, 2, x sub 2, y sub 2 as 12, 6. Now, there's a disclaimer also. Why do I, there's a reason, I don't know why, but I like using the word disclaimer lately. I don't even know what it exactly means, but anyway, my point is, it doesn't matter which one is your first point or your second point, as long as you label it correctly. If you don't believe me, what I'm going to show you here is based on the PowerPoint, but if you want to try, why don't you try to make 6, 2 as your second point and your 12, 6 as your first point? And if you do it properly with your substitution, your answer will still be the same. The most important thing here is the representation. Just like in your love lives, if you have any, the most important thing there is labels so that you know your limitations, you guys know what to do. I don't know where I got that from. I don't even have any. But anyway, so if you do that, use the distance formula, you're going to get what? 6 minus 2, 12 minus 6. 6 minus 2 is going to be 4 raised to 2. 12 minus 6, so 6 raised to 2. And if you simplify that, the square root of 52. And as I have mentioned to you guys before, square root of 52 can be simplified. Okay, so it's going to have 2 square root of 13. Okay, so you have to be careful of there. Some of them can be simplified kasi. Okay, it's 2 square root of 13. So hence, the zip line is 2 square root of 13 or approximately 7.21 feet. Look at Jenny and Lisa, they're so happy, right? So that is for distance formula so far with the word problem. Now let's try to have one more example proving geometric properties. So in order to prove this kind of concepts, you don't have to overcomplicate it. It just simply asks you to solve, okay, if it's correct. So it states here that we want you to show that ABC is isosceles. Even though we don't have the drawing of the triangle, we can identify if it's isosceles, scalene, or equilateral by simply applying the distance formula and finding the lengths of each side. So just like earlier, let's find the measurements of AB, AC, and BC. Using the formula here, you already have A and B. So negative 1, 1, B, 1, and 4. So those are your 2 points. By proper substitution, you're going to get something like this. And your answer is going to be square root of 13. As quick as that, right? I don't have to spoon feed you guys with the substitution now, right? At this point, hopefully. But I just want you to get the process. Okay? Again, AC, that's going to be point A and point C. Okay? You can make your A as your first point, your C as your second point, and or vice versa. It still works. And if you do that, proper substitution, your answer here for AC is equal to the square root of 16 or 4. Then for BC, substitute the point B and point C. You're going to get this, and your answer will be the square root of 13. And just like earlier, we can notice that AB and BC have the same measurement, being square root of 13. Hence, this triangle is isosceles. Okay, I hope you guys understand that. Now let's have one more here. A triangle has vertices A, 0, negative 5, B, negative 2, 1, and C, 10, 5. Now we want to show if it's a right triangle. In order to do this, first off, the most important part is we substitute them. Don't overcomplicate that part. So by substitution, have side AB using A and B, side AC we use A and C, side BC we use B and C. So if you substitute that, you're gonna get AB like this, and your answer is square root of 40. And then for AC, substitute properly, solve, and please, 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 please. The reason why we're showing you the complete solution here is because we want you to understand that if you're gonna rely on your calculators, the first part of this solution is the most important because that's how you're gonna type it. That's how you're supposed to type it. There's actually a correction here. There should be an additional parentheses here for AB, okay? Similar to AC. Because if you don't do that, your answer will be different, okay? There's a correction here. Thank God I noticed that. Okay. BC is correct. That's how you type it in your calculator. If you want to do it manually, it's the one we're showing on the screen, and the answer here is square root of 160. As you can notice, sir, aren't all those things simplifiable? Actually, yes. But the reason why we're not simplifying it here because it would be much easier to solve for it in order to prove if it's a right triangle. Because all we have to do is to substitute. Now, to prove if something is a right triangle, all you have to do is to use the Pythagorean theorem. The Pythagorean theorem is as simple as that. C squared is equal to a squared plus b squared, right? So in this case, the reason why AC is our hypotenuse is because compared to the other sides, it's the longest. The hypotenuse will always be the longest side. So in this case, if you substitute this, you're going to get 200 is equal to 40 plus 160. 200 is equal to 200. Hence, it's equal. This implies that it is indeed a right triangle. As quick as that. Sorry if I'm discussing it this way because I want you guys to understand that it's not meant to be complicated. The most important part for distance formula and midpoint is you know your x sub 1, x sub 2, you know your y sub 1 and y sub 2, and you be careful with the negative ones, okay? Because the formula is minus. It doesn't mean that if it's negative, it's just minus the number. No, minus negative pa rin siya dapat. Like 10 minus negative 2, okay? So, that's it. ABC is a right triangle. Let's now go with midpoint, and we're not gonna make this complicated. Please, let's not make this complicated. The midpoint is basically about the middle point. That's why midpoint, meaning it's the equal distance from this point is equal distance with A and with B. So if we solve for this, it's actually the easiest still using the 2 points, right? X sub 1, y sub 1 for the first point, and x sub 2, y sub 2 for the second point. And it's as easy as this. To get the midpoint, again, the word is midpoint, middle point. The point is a point, so it should have coordinates, hence the parenthesis here. So to get the x value of the midpoint, all you have to do is to add the x values of the 2 points divided by 2. We're dividing it by 2 because it's the middle, the half. And then y sub 1 plus y sub 2 divided by 2. As quick as that. That's your midpoint because it's the distance between 2 points. Okay? That's the midpoint. You don't have to make it complicated. So let's have some examples here. It says here that A is at 1, 4, B is at 13, 10. You can actually do this mentally. Like the x's here are 1 and 13. If you add that, that's 14. Divided by 2, that's 7. So your x value for your midpoint is 7. And for your y, you have 4 and 10. 4 plus 10 is 14. Divided by 2, you get 7. So the midpoint here is supposed to be 7, 7. As quick as that. You don't have to make it complicated. But again, kiddos, if it can be simplified, simplify it as much as possible because you guys are moving to senior high school, college. Dapat alam nyo na 14 divided by 2 is 7, okay? You have to simplify that if it's simplifiable. Now let's have some more examples. Now these are the last set of examples because it's that easy. Now how to make it complicated. You can do it mentally, like 5 plus 7, that's 12. Divided by 2, it's going to be 6. So your x here is 6. 2 plus negative 8, that's going to be negative 6. Divided by 2, that's going to be negative 3. So let's see if we're correct there. 6 negative 3 is the answer. Again, be sensitive with the substitution, with the sign. 2 plus negative 8 is like 2 minus 8. But let's see. Are we correct? Yes, it's 6 negative 3. As quick as that. So if you want to try the others on your own for the meantime, I'll try it out for like 5 seconds. You can pause here so you can work on it. Was that 5 seconds? I don't know, but let's go. C and D, like 8 plus 2 divided by 2, then negative 2 plus 4 divided by 2. You cannot type this in your calculator, class. Baka wag naman sana, guys. It's just adding, please. You have to know that by now, okay? I'm just saying that because I'm really concerned about you guys. So 8 plus 2 is 10 divided by 2. Then negative 2 plus 4, that's 2 divided by 2. 10 divided by 2 is 5. 2 divided by 2 is 1. And that's it. While for E, it's going to be negative 1 plus negative 2, negative 10 plus negative 10. Negative 1 plus negative 2 is negative 3 over 2. Sorry, negative 3 and then over 2. Negative 10 plus negative 10 is negative 20 and then over 2. Now, in here, as you can see the answer, negative 20 divided by 2 is negative 10. And some of you guys might ask, sir, can I put this in decimal? Yes naman, it's okay. But if your teacher tells you to put it in fractions, just stick with fractions. Okay. The reason why I'm okay with my students putting this in fractions in decimals is because it's gonna be just 0.5 anyway. Like negative 3 divided by 2 is negative 1.5. It's not a complicated decimal. There's no problem with that. It's still exact, not like 0.333. It's not repeating. Anyway, last example. Let's add negative 5 and 4, then 4 and 1. And then let's get the answer, and that's it. You can have this as negative 0.5 and 2.5. That's it. That's your final answer. That's distance formula and the midpoint formula.
And that ends the video. I hope you guys liked it. I sure do hope that Coco liked it. So the Little Prince has a fox. I have Coco on my side. I think this one's good. So yeah. So, well, we're gonna be more and more different with the way we present things, not just here, but also in real life, whatever that may be. I just wanted to say that because, you know, I'm really trying to enjoy all these things, and I just want you to enjoy all of so yeah. If you want to listen to more yaps, you're gonna hear a lot more as we move forward. And like always, in case you don't see me, good morning, good afternoon, good evening, and good night, everybody. Peace out, respect.